NASA found a huge hole on Mars that could lead deep underground and possibly hide signs of life. The gaping pit is about 300 feet wide and is located in a bizarre area full of voids and openings. Most of them are shallow, but one hole stands out. It looks much deeper and seems to break through into a lower level of the planet. The origin of this pit is still unclear. Could it be an ancient civilization that built an underground city to live inside the planet? Scientists think something more powerful could have created it. One of the main ideas is that a meteor crashed into Mars and punched through the surface, leaving this deep opening behind. This hole is especially interesting for us because it might connect to a huge system of tunnels or caves. In there, conditions are much safer than on the surface, which is extremely cold, full of radiation, and often hit by dust storms. That's one of the reasons why those underground spaces could protect and possibly support life. This makes them one of the best places to search for it on Mars. Billions of years ago, Mars was likely much more like Earth, with conditions that allowed life to develop there, but over time the planet changed a lot. These days, Mars does not have a strong magnetic field or a thick atmosphere. This means its surface is exposed to fatal radiation from space and the sun. This radiation is powerful enough to wipe out any living organisms. So if life still exists on Mars, it's more likely to be hiding underground. Places like deep caves can act like natural shelters since they can block radiation and keep conditions more stable. One day, we might build the first human base on Mars inside an old inactive volcano. Old volcanoes on Mars might have long tunnels called lava tubes. They formed when hot lava flowed and then cooled, leaving empty spaces inside the rock. These tunnels could protect astronauts from radiation and extreme conditions, making them a good place to live and work. In 2019, scientists from the USGS Astrogeology Science Center created a map showing more than 1,000 possible cave entrances on Mars. But scientists still don't know how deep those caves go or how large they are. At the moment, NASA uses rovers and satellites to explore Mars. But in the future, astronauts might be able to study those underground areas more closely. These missions could search for signs of life, such as tiny fossils or chemical traces left by past organisms. You could get to Mars in just 30 days. No, this isn't sci-fi. A new breakthrough plasma engine could actually make it happen. Pretty soon, we might be swapping our beach chairs in the Bahamas for a trip to the Red Planet. So, when can we buy our tickets? Well, probably not until 2030. And even then, those first rides will probably be a luxury reserved for astronauts, not tourists. They're already thrilled though, because this engine could change everything about space travel, cutting flight times way down and making missions a lot easier to handle. Right now, traveling to Mars is just a dream. Nobody's ever set foot there, and there's one big reason why. A round trip would mean spending years stuck in space. And that's anything but safe. We did send people to the moon though, but that's a whole different story. Getting to our natural satellite only takes a few days. The fastest trip was Apollo 8, when the crew made it from Earth's orbit to the moon's orbit in just under 3 days. If the team wants to save fuel, they might choose a different route to get there. And those paths can take way longer, sometimes weeks, even months, before they finally reach the moon. So how long it takes to get there is more of a strategic choice. Now, what about Mars? Well, the Red Planet is a lot farther away. On average, it's about 140 million miles from Earth. According to NASA, even if you could hop on a spaceship right now and head straight there, the trip would take anywhere from 7 to 10 months. Take NASA's Mars Reconnaissance Orbiter, for example. This spacecraft launched from Cape Canaveral in August 2005 and didn't reach Mars's orbit until March of the next year. How long the trip takes can change though. That's because the distance between Earth and Mars is always changing as they orbit the Sun. So even if we can get there in a few months, a round trip could end up taking nearly 3 years. And nobody wants that. Not just because it'd be boring to live up there without Netflix, but because it's seriously risky. Spending that much time in space can do real damage to the human body. You see, a mission to Mars would put astronauts through 3 different gravity fields. First, during the trip to Mars, they'd be weightless. Then once they arrive, they'd have to live and work in a gravity that's only about a third as strong as Earth's. And finally, when they come back, they'd have to readjust to Earth's gravity. Switching between all those gravity fields is no joke. Astronauts can lose their balance and sense of direction, which can cause nausea and confusion. Dealing with that while landing a spacecraft on Mars is definitely not fun or easy. That's just one set of problems. There are plenty of other challenges with a trip this long, like a communication delay of up to 20 minutes one way, the risk of equipment breaking down or medical emergencies, and the constant need to carefully ration food and supplies. Thankfully, the new engine I mentioned earlier might just save the day and could make the trip way shorter, or at least that's what scientists are saying. They've built a prototype of plasma electric rocket engine that could get us to Mars in just 30 to 60 days. And if your first reaction was, a plasma what? Don't worry, I'll explain. So, here's a normal rocket, the kind you see blasting off from Cape Canaveral. It works by pumping liquid hydrogen fuel and liquid oxygen oxidizer into its engine. When the fuel burns, it releases a ton of energy, creating thrust. In simple terms, that burning makes super hot gas that blasts out the back, pushing the rocket forward, and off it goes. Now, here's the plasma rocket. It takes off pretty much the same way using the same chemical mix to launch. But once it reaches orbit, it switches over to an electric propulsion system, and it works completely differently. Instead of burning liquid hydrogen and oxygen, it uses two electrodes. When charged particles move between those electrodes and a high voltage is applied, the current creates a magnetic field that pushes the particles out of the engine. That superheated plasma shoots out in one direction, and the spacecraft moves in the other. That's how it creates thrust. We're talking about at least 6 newtons of thrust. To give you an idea, 1 newton is about the same force it takes to hold up a small apple against gravity. Sure, that sounds tiny compared to the explosive power of a normal rocket, but here's the thing. A plasma engine can run non-stop for months, gradually accelerating spacecraft to extremely high speeds. Cool, but how fast are we talking? Well, regular rockets that burn fuel can reach a maximum exhaust velocity of about 2.7 miles per second. Meanwhile, this new plasma rocket can hit around 62 miles per second. At those speeds, a rocket trip to Mars could only take a month. That's a huge difference. That's why people think this new engine could completely change space travel. By letting spacecraft go way farther while using a lot less fuel, this tech might finally be what we need to leave our footprints on the Martian surface. And who knows, maybe even go beyond that. But it's not exactly ready yet. It could take years. Right now, it's more of a prototype, still in a very early stage of development. It's being tested inside a special facility, a 46-foot-long vacuum chamber about 13 feet wide that simulates the conditions of space. The whole idea is to see how the engine performs in realistic conditions before actually sending it into orbit. One of the things they might want to test is how it reacts to gamma-ray radiation. Because out in space, radiation isn't just sunlight. It's streams of tiny subatomic particles coming from the Sun, the Milky Way, and even beyond. They may be small, but they're still a major challenge for long missions. Because here on Earth, radiation from the Sun and space isn't a big deal. Our atmosphere and magnetic field absorb or deflect most of it. But astronauts and their spacecraft don't have that kind of natural protection out there. The problem is that these high-speed particles can pass right through the human body. They can tear through DNA molecules, breaking them apart and causing serious health problems. Even just an hour without proper shielding could be life-threatening for us. Well, for the astronauts, I mean. But it's not just humans. Spaceships take a hit too. These particles can penetrate the spacecraft's materials and damage sensitive electronics, causing glitches, malfunctions, and even complete failure. That's the last thing you want on a long space trip, right? It's not like there's a pit stop with a mechanic on the way to Mars. And with a round trip taking over a year, That's a huge problem. The longer astronauts and their ship are exposed, the higher the risk. That's why finding ways of getting to Mars faster is so important. But the creators of this plasma engine are not the only ones racing to get to Mars with faster rockets, though. NASA recently teamed up with the Defense Advanced Research Projects Agency to test a nuclear thermal rocket engine in space, a technology that could also cut down travel time for future human missions to the Red Planet. Meanwhile, SpaceX has even bigger ambitions with their colonization program, better known as Occupy Mars. Their plan is to send people to actually live on the Red Planet, hoping it'll help humanity survive in the long run. They're planning to launch the first starships there in 2026, but they'll probably still be uncrewed. The scientists are confident that those ships make it to Mars in just 6 months. So, we've got a plasma engine, a nuclear thermal rocket, and a whole Occupy Mars mission all racing to get people to Mars very soon. But who is really going to pull it off first and get there the fastest? I guess only time will tell. But hey, you can drop your guess in the comments.
Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the Red Planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the Red Planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the Red Planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the Red Planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the Red Planet. All thanks to the Mars Insight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the Red Planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be, or what it could be like one day. And if once Mars had a lot of water, It could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars. But for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.